So we're going to continue on with our scientific notation. Before we get started into our small numbers, I just want to revisit some basic revision for you. So 1 times 10 to the power of 1 equals 10. And we know this because any number that is the power of 1 is also always its own number. Therefore, that just equals, let me write in a different colour, essentially all it's saying is 1 times 10 equals 10. You will remember from other classes, 1 times 10 to the power of 0 equals 1. Moving on, 1 times 10 to the power of negative 1. So in this case, we're going less than a whole number. So we're going backwards, so it's going to be a smaller number. So how we could express this is, here we've got 10 to the negative 1. So we could write that as 1 over 10, which equals 0.1. So now here we are less than 1. So we're becoming smaller. Let's go a little bit further. 1 times 10 to the negative 2. We could express that as 1 over 100. So we're getting this negative 2 zeros, which is 2 zeros here, equals 0.01. Let's try one more just to get the idea in your head. 1 to the power of 10, 1 times 10 to the power of negative 3. We would write this as 1 over 1,000 because we have 3, and this is our 3 zeros, equals 0.001. And here we can double check. We have, here is our decimal place. If we're going to move it 1, 2, 3, 1, 2, 3, lo and behold, that is how much we have here. And the reason why it's negative is because this here, it is less than 1. Okay, so it's going into very, very small numbers if we were to continue. Okay, so let's look at a really small number. So here, let's say we're looking at the diameter of an atom. So 0.0000001 centimetres. So we're talking very small. You wouldn't be able to see it with the naked eye. So rather than writing that massive, when I say massive, I mean very small number but long number, we want to be able to talk about it or be able to rewrite it in a concise manner. So again, just like before, this decimal point here, we want to move it all the way back over to here. So in this case, this number here would then become 1. Okay, multiplied by 10, because remember we're talking decimal places, and we're counting them back. 1, 2, 3, 4, 5, 6, 7, 8. Let me write that in there so you can remember. 5, 6, 7, 8. So in that case, we have 1 multiplied by 10 to the power of negative 8. Now it's negative because it is less, so it's less than 1. So basically when we're dealing with small numbers, the exponent will be negative. Will be negative. So i.e. in this case it was 10 to the power of negative 8. Okay, so let's have another look here. I'll make my pen a little bit finer. So here in this scientific notations, right here, we're looking here and it says 1 to the power of 10, 1 times 10 to the power of negative 9. So here, get a different pen, we're moving this decimal point back over here. And if we're counting correctly, it should get us 9 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So because we're going backwards, we're moving it to the right, the decimal point. It is negative 9, which is correct. Same with this next one. 1, 2, 3, 4, 5, 6. So it's negative 6. 1, 2, 3, negative 3. Correct. 1, 2, negative 2. Remember, in here, as the start of this presentation, anything to the power of 0 is always 1. And just a quick refresher of what we did yesterday, when we're moving the decimal point to the left. So 1 times 10 to the power of 3 basically gives us, and how we're working that out, we have 1, okay, but we want to move it 3 times, so therefore it would be 1, 2, 3, so that gives us 1,000, which is what we have here. Same again, we've moved it 6 times, so there's 6 zeros, and again down here we've moved it 9 steps, so it's 9 zeros.